Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics in Department of in Faculty of Education and Methodology, JAYOTI VIDYAPEETH Women's University, Jaipur. So I'm going to take a lecture on the topic of differential equations and its a solution. This topic is a part of the course Business Mathematics and under the program of BBA and BBA LLB. For second semester, BB and BB LLB second semester. So the today's topic is of differential equation. Differential equation is a very important part of mathematics. As already we know that this differential equation is an equation which contains the independent variable and the dependent variable and the derivatives of dependent variable. So as similar to other equations like algebraic equations or the different transcendental equations, differential equation just will consist of the various terms, but it also consists of a derivative term, and that's why it is called a differential equation. And this differential equation can be solved by the various methods. So first we see what a differential equation. A differential equation means a mathematical equation and that contain independent variable, dependent variable and the derivative of the unknown function. What is meaning of unknown function here? The unknown function means that is called a dependent variable. For example, suppose if I take x as independent variable and y as a dependent variable of this, it is depending upon x, then the unknown function means here y, which is also called fx. So the derivative of a dependent variable means dy by dx, and the differential equation means it is an equation that consists of the derivative terms. It is compulsory to consist of derivative term, and the solution of differential equation means it is solved for the dependent variable, that means for the unknown function. The derivative means the derivative of a function defines the rate of change of a function. As already we know that in the concept of differentiation, there is a term derivative. Suppose if I say here dy by dx, it means dy by dx is showing here the rate of change of a function y, that means it is function fx with respect to variable x. So the rate of change of a function will always come in the numerator part, and the independent variable that will come always in the denominator part. So these derivatives and the other functions are related by a differential equations. So ultimately we can also define that differential equation means a kind of relationship between the independent and the dependent variables and the derivatives of the dependent variable. Differential equation just plays a very important role in all the different subjects of science, engineering, and medical, as well as and the different subjects, applied subjects of science, because the research part with the derivations will consist of differential equations, and the main thing is that how to solve a differential equation. So right now we are just defining here order and degree of a differential equation. First, we will understand what is meaning of order of a differential equation. The highest order of the derivative that appears in a differential equation is called its order. Means, suppose we are given that an equation, a differential equation, then the order of differential equation means the order of the highest derivative that is present in the differential equation is called the order of differential equation. So it means highest order derivative which is present in differential equation, its order will decide the order of differential equation, and that will be same. Now, what is meaning of degree of differential equation? The degree of differential equation means the degree of a differential equation is the integral part of the highest order derivative that arises if the differential equation can be expressed in the polynomial form. So it means if the equation can be expressed in the polynomial form, then the degree of the highest derivative present the degree of the highest order derivative present in the differential equation is the degree of differential equation. Okay, so it means just we can say, or degree of differential equation means the we have to see first what is order term of differential equation, and after that the degree means the exponent or the integral part of that term just will be the degree of that equation. The power of the differential equations is the highest order derivative indicates the equation's degree. And one point that is to be noted here, very important point, to find the order and the degree of a differential equation, the differential equation must be independent, must be free from the any radical term or the derivative term that will come in the denominator. Okay, so it means first we have to arrange our equation, differential equation in a proper or proper way. That means the derivative term and the dependent variable dependent term that should come in the numerator. So derivative term should come in numerator, and just after rearranging the differential equation in a proper form, then we can just give its order and degree. One more important thing, that is the radical terms. The differential equation should be independent from the radical terms of derivative and the dependent variable and means here y and its derivatives. So look at here some example to explain this here. In the first example, we are given that an equation, that is d square y upon dx square plus dy by dx is equal to 3y cos x. So this is called the differential equation. Here we can see the highest order derivative, that is d square y upon dx square, is present there, and that is the second order derivative term. Dy by dx is the first order derivative term. So ultimately the order of differential equation is a 2 there, because the in the equation, in the this given equation, what is the highest order derivative term in the present in the equation? That is order 2 term. So look at it, this one here, d square y upon dx square, that is second order derivative term, that is highest order derivative term present in that equation. Therefore, its order is 2, while its degree will be given by 1. Why the degree is 1 there? Because the exponent of this highest order derivative term is 1, and therefore that is the degree of that differential equation. Now, next example, in the second example, we can see there the whole equation. There is a one term of second order, and there is a one term of first order, and a term 5x square is not containing any derivative term. So ultimately, this is a differential equation. And what should be its order? Its order, we can see there, the order means the highest order derivative that is present in the differential equation. And now we can see in this equation, second order term, second order is the highest order that is present in the differential equation. So ultimately, again, the order will be 2 for this equation, and degree will be 1, degree will be 4 there, because this highest order term is having exponent as a 4 there. So just 4 is called its a degree. So in this way, we can determine the order and the degree of a differential equation. And next, the solution. Any kind of equation definitely just is important for that one. If just how to solve that equation, that is a very important point, because when we solve this equation, then we will get its a solution. And solution means the differential equation give a kind of relationship between the variable and the constants. So in the case of the differential equation, what is meaning of the solution? An expression for the different dependent variable in terms of the independent variable that satisfies the differential equation is called the solution of differential equation. Means the solution of the differential equation can be defined as a kind of relationship, a kind of relation between the independent variable and the dependent variable, and where we can more specifically explain that where the dependent variable is expressed in the terms of the independent variable, but the condition is that the relationship which is obtained in terms of independent variable and dependent variable, that should satisfy the given differential equation. If it satisfies the given differential equation, then it is called the solution of that differential equation. If it does not satisfy, then definitely it is not the solution for that differential equation. Now, solutions of the differential equation can be divided in various forms. So first of all, we take the general solution. What is meaning of the general solution in a differential equation? First, we see this one. The solution that contains as many arbitrary constants is called the general solution. Means in the given differential equation, the number of constants, the solution that contains as many arbitrary constants as the order of differential equation is called the general solution. So just the solution that contains as many arbitrary constants is called a general solution. If we give particular values to that arbitrary constant, suppose we are assigning some particular values to these arbitrary constants, then the solution which is obtained for the differential equation is known as the particular solution. So suppose if we have a solution like y is equal to x plus c. Now this y equal to x plus c, because there is a one constant c, so this constant is showing because one constant is there. So this is called the general solution for the first order differential equation, because if one constant is there, arbitrary constant is there, then definitely its order should be one. So that is called the general solution. Means if the number of arbitrary constants is equal to the order of differential equation, that then it is called the general solution. And the particular solution, suppose y equal to x plus c is the solution for general solution for that equation, and if we assign any particular value to that constant, suppose I am assigning here c equal to 5, then this solution like y equal to x plus 5 is called the general solution. Sorry, it is called the particular solution. So ultimately, just we have to assign a particular value to that constant, and that will then it will be called a particular solution. The result of eliminating the arbitrary constants yield a first order differential equation, and that of eliminating two arbitrary constants leads to a second order differential equation, and so on. Just I have already explained that. Then like general solution will be the solution which is having as many arbitrary constants as the order of differential equation. So it means the result of eliminating one arbitrary constant. So suppose just when we are having a one arbitrary constant and we eliminate that constant, then it will give us the differential equation of first order. Now, suppose in another case, if we are having the two arbitrary constants and just we eliminate these two arbitrary constants, how can we eliminate these? just by taking the solution and by taking its derivatives. So if we eliminate these two constants, then definitely the differential equation for these two arbitrary constants elimination will be a second order differential equation. Okay, next, just we take the various methods to solve the differential equations, because when an equation is formed in any kind of problem, in any kind of research paper or whatever, just then it is important how to solve that equation. There are various methods to solve differential equation in the present time, like analytical methods, as well as the numerical methods are there by which we can solve these differential equations. So, first method that is called the variable separable method for solving the differential equation is going to be discussed today's lecture. Just we are discussing the first method, that is variable separable form. Variable separable form means that is a form of a differential equation in which the two different sides of the differential equation will consist of the two different variables. Means in a very simple language, suppose a differential equation is having the one side consisting only the variables of x and the other side will contains the terms of y. uh, as we can see in this example there, suppose here the left hand side is consisting here the terms of x, for example fx dx is there, and the right hand side is consisting the terms of y, that is gy dy. Then such type of equation is called a variable separable form, and it is the basic or the beginning method for the solution of differential equation. And how can we solve this form? Just we have to integrate both sides of a differential equation to get its general solution. So look at here. For example, suppose if we are having a differential equation sin x dx is equal to 5 plus y uh, into dy. So look at this form there. Just already this form is in the variable separable form, because the left hand side is consisting only the terms of x, while the right hand side is consisting the terms of y. And when we integrate this equation, then we will get its a general solution. So look at here, when we integrate sin x, then we will get minus cos x. And when we will integrate 5 plus y, then it will be 5y and plus y square by 2 plus c. So ultimately, a variable separable form can be integrated directly to give its a general solution. And if this arbitrary constant c is just substituted by a particular value, then it is called a particular solution. So that is the method to solve a differential equation by the variable separable form. So this is the first method to solve a differential equation. And in the today's lecture, we have discussed about the concepts, the meaning of the differential equation, and its order and degree, and their solution. Like means what is meaning of general solution, particular solution, and the one of the method that is called variable separable form. So with this, I'm concluding today's lecture. Thank you.